Welcome students, you have seen the assignment sent to you. I just quickly go through these questions. Write formulae of the following compounds, also calculate their molar masses. So firstly you have to write the formulae, and I had given you earlier about the various ions and their valencies. So now you have to use them, and then you have to calculate their masses. In second question, you have to find out the percentage composition of each element in the following compounds. So in this question also, first you have to write the formula for potassium nitrate, then sodium sulfate, and so on. And then you have to find out the percentage composition. And last question is basically for moles. So I hope you remember all the elements and their valencies. But just to revise the whole thing, I bring your attention once again to various atomic masses. Okay students, I hope you have learned this table. In case there is still some problem, you should try to do it again, once again. Now various elements are as shown on the screen are now hydrogen, helium, and so on. And as you are aware of, on the left side when their serial number is there, that is basically atomic number also, because atomic number is based on serial. So 1, 2, 3, 4, 5, 6, 7. 7 is nitrogen here. If you see, 7 is nitrogen. But I have written it this way. It means what? It means atomic weight is always written at the top and atomic number is written at the bottom. So say I have to write for let's say oxygen. So if I have to write for oxygen, what I'll do, here we are. So to write oxygen, first I will write atomic number. So atomic number is 8 and atomic weight or mass number is 16 here. So it becomes 8O16. Say I want to write for calcium. I want to write for calcium. So for calcium, what I'll do? I'll do calcium, 20 is atomic number and 40 is atomic mass. This will help you to learn it quickly. Anyhow, now we'll be going for our assignment. In case you have not learned this yet, I suggest pause this video for a while, note down all the elements once again, learn them, and then try to attempt question number 1. So we are back to our assignment. I presume now that you have learned this table by heart. So, okay students, let us also examine the list of positive ions and negative ions once again. Now positive ions are shown on the left side. Hydrogen H positive, sodium Na1 positive, silver Ag1 positive, potassium K positive, lithium Li positive, ammonium NH41 positive, barium Ba2 positive, calcium Ca2 positive, copper 2 Cu2 positive, zinc Zn2 positive, magnesium Mg2 positive, lead that is lead 2. I have written once again down below also for your help. It is Pb2 positive, iron 2 Fe2 positive, iron 3 Fe3 positive, aluminium Al3 positive. So lead is again shown separately. Lead 2 Pb2 positive, tin 2 Sn2 positive, lead 4 Pv4 positive, and tin 4 Sn4 positive. So these positives are basically the valencies which shall be using in the while we make write various chemical formulae. Then the negative ions which are of help are as shown: chloride, bromide, fluoride, iodide with 1 negative valency, hydroxide OH 1 negative, nitrate NO3 1 negative, oxide O2 negative, sulfide S2 negative, sulfate SO4 2 negative, carbonate CO3 2 negative, hydrogen carbonate HCO3 1 negative, sulfate SO3 2 negative, nitride N3 1 negative, phosphide P3 1 negative. Just correct it, nitride is N3 negative and phosphide is P3 negative. No, it's written correctly. Then hydrogen sulfate, it looks like sulfate but it is not sulfate student, it is sulfite. Hydrogen sulfite, it is SHO3 1 negative. Then acetate CH3COO 1 negative, cyanide CN1 negative, oxalate C2O4 2 negative, peroxide O2 2 negative. So you must learn all these by heart if you want to write chemical formulae correctly. So now we start with today's assignment. First question is write formulae of the following compounds and also calculate their masses. So let us first write various formulae. So first one is potassium nitrate. So if you see the table which you have just noted down, So compound to be written is potassium. So I write for you potassium nitrate. So if you see that table, potassium we find is K positive and nitrate is NO31 negative. So what I'll do, I'll exchange valences. When since nothing is written over there, we take it 1. So this one comes here and this one goes here. But now this one can make it 31. So we put whole nitrate in the bracket like this so that there is no confusion. So this formula now becomes, students, KNO3. But we don't write 1 as you understand. So it is KNO3. The next is sodium sulfate. So first write sodium sulfate. So please refer to your table once again, which you have just noted down. Sodium sulfate. Sodium is Na1 positive and sulfate is SO4 2 negative. So now first step you have to do is exchange the valency. So Na2, just forget about negative or positive sign, they don't bear any consequence here. So Na2SO4, again 1 has got no logic to be written. Then comes next compound is sodium carbonate. So sodium, if you refer to table once again, sodium carbonate. Sodium is, students, Na1 positive and carbonate is CO3 2 negative. Again exchange the valencies. So this becomes Na, correction, I just corrected for a while. So this becomes NaCO3, correction, Na2CO3, because 2 comes here. The next compound to be written is sodium hydrogen carbonate. So it is sodium hydrogen carbonate. So just see the table again. It is sodium Na1 positive and carbonate is HCO3 1 negative. So again 1 simply you can forget about this and then just write NaHCO3, since 1 and 1 they are same. Then comes after sodium hydrogen carbonate, there are few formulae which you must remember. Now sulfuric acid. Sulfuric acid is H2SO4. H2SO4. Then comes acetic acid. Acetic acid. Now acetic acid is a weak acid, otherwise it is acetic acid is CH3. It is CH3COOH. After acetic acid we move to next compound. Next is nitric acid. So nitric acid is nitric acid. So nitric acid, students, is HNO3. HNO3. Then comes aluminium chloride. Aluminium. So again refer to your table, because here you have to first write the formula. So formula is Al, correction here, again I just do it, just to write formula. First we have to see aluminium. Aluminium is Al3 positive and chloride is 1 negative. So just exchange the valencies. So they become, this becomes rather AlCl3. Then next is calcium oxide. So when we say calcium oxide, now calcium is Ca2 positive and oxide is 2 negative. So 2 and 2 cancel out. So simple formula becomes CaO, because there is no point first to be written Ca2 and then O2 and then cross it. So after calcium oxide we have got sodium hydroxide. So sodium hydroxide. Now when you say sodium hydroxide, students, sodium is Na1 positive, hydroxide is OH1 negative. Keep referring to your table while I am doing this. This becomes NaOH. After sodium hydroxide we have got calcium hydroxide. So calcium hydroxide. Now here we have to be slightly careful. Calcium is Ca2 positive and hydroxide is OH1 negative. So now when we say OH1 negative, this 2 will be applicable for both when we exchange the valencies. So how to do it? So for doing this, what we write, Ca, one valency comes here, one valency comes here, Ca, Now OH we will put in brackets so that this twice is applicable both for O as well as H. If you don't do it, if you write CaOH, then OH2, so then it is only for H2, which is wrong. So correct is CaOH twice. Well, students, after writing chemical formulae, now we have to write the molar mass. Molar mass, or as we call it, molecular mass, or molecular weight also, molar mass or molecular weight. Now when we have to write molecular weight, then we have to first see the formula. So now first formula as we have written is potassium nitrate. So potassium nitrate is KNO3. Now critically we have to see how we proceed. If you see K has got only one atom. See its atomic mass. If you see the table of atomic masses, you find atomic mass of K is 39. So I'll write 39. Plus nitrogen is 1. So I write 1. And if you see its atomic mass, this is 14. 7 and 14. So we are using here masses only, remember. Plus there are 3 atoms of oxygen, and atomic mass of oxygen is 8O16. So 3 into 16. So this becomes 39 plus 14 plus 48. Just total them up. So it's 8, 4, 12, 9, 21. 2 carried, 4 to 6, 7 and 3, 10. So this is how you will complete. This is molar mass in gram. Now second formula is, students, sodium sulfate. Sodium sulfate, as we have written earlier, is Na2SO4. So we have written here sodium sulfate. So this is sodium sulfate. Now this sodium sulfate is Na2SO4. Again, see the number of atoms, each atom. Sodium is 2, so 2 into 23. Sulfur is 1, so 1 into 32. Because if you see sulfur in the table, it is 16 as 32. So we'll use 32 plus 4 into 16. Oxygen is 16 here. So this becomes 46 plus 32 plus 64. So this is, if you add them, add all the 3 here. So this is 64 plus 46 plus 32 comes out to be, so 142 grams, like this. Then we move to next formula. Now next is sodium carbonate. Now sodium carbonate is Na2CO3. So to write Na2CO3, what I write, 2 into 23 plus 1 into carbon is 12 plus 3 into oxygen is 16. So this is 46 plus 12 plus 48. So if you add all these, this becomes 106 grams. That is sodium carbonate, Na2CO3. So I have written 2 atoms of sodium, 1 atom of carbon, 3 atoms of oxygen, and then their atomic masses multiplied, then these, and then what we get, we add them. So then this becomes sodium carbonate. After sodium carbonate, we have got sodium hydrogen carbonate. Now sodium hydrogen carbonate is NaHCO3. So what to do now? Na is 1 only, so 1 into 23, plus hydrogen is 1 only, so 1 into 1, plus carbon is 1 only, so 1 into 12, oxygen is 3, so 3 into 16. So this comes out to be 23 plus 1 plus 12 plus 48. So if you add these, the total is 84 grams. After sodium hydrogen carbonate, we go for sulfuric acid. Now sulfuric acid is H2SO4. So similarly, H2SO4 means 2 of hydrogen into 1 plus 1 of sulfur into 32 and 4 of oxygen into 16 atomic masses. So this comes out to be 2 plus 32 plus 64. So this is 98 grams here. After H2SO4, we move for acetic acid. Now CH3COOH. So here carbon is 1 and 1, 2. So 2 into 12 plus hydrogen is 3 and 1, 4. So 4 into 1 plus oxygen are 2. So they are 2 into 16. So this comes out to be 24 plus 4 plus 32. So when you add them, it comes out to be 60 in grams. After acetic acid, CH3COOH, we go for nitric acid. So nitric acid is HNO3. So HNO3 means 1 nitrogen into 1 plus 1 nitrogen into 14 plus 3 oxygen into 16. So this is 1 plus 14 plus 48. So if you total them up, this comes out to be 63 grams. After HNO3, we have got that is after nitric acid, we have got aluminium chloride. Now aluminium chloride is AlCl3. Here aluminium is 1 into 27. Refer to your table again. Chlorine 3 into now if you see chlorine plus 3 into chlorine is 35.5. So 27 and 35.5, this comes out to be 27 plus. Now again multiply these two. So what you get here is 27 plus 106.5. So 133.5 grams. Then we move for next compound. Next compound, students, is calcium oxide. So calcium oxide, already we have written the formula. If you remember, calcium oxide is CaO. So here it is CaO. So when you say calcium oxide is CaO. So I write CaO. I will check atomic mass of calcium. Only one atom. So 1 into 40 plus I will check for oxygen 1 into 16. So this comes out to be 40 plus 16 is equal to 56 grams. After calcium oxide, let us go for sodium hydroxide, NaOH. So NaOH is again quite simple. Na is 1 into 23 plus oxygen is 1 into 16 and hydrogen is 1 into 1. So it comes out to be 23 plus 16 plus 1. So if you add these two, all three rather, it comes out to be 40 grams. After sodium hydroxide, we go for calcium hydroxide. So CaOH twice. Now in case of calcium hydroxide, what we'll do, Ca. Now Ca is 1 into 40 plus. Now this twice is for the whole bracket. So remember this. That's why we write 2 into O is 1 into 16, H is 1 into 1. So it comes out to be 40 plus 2, 16 plus 1. So this is 40 plus 2 into 17 is equal to 40 plus 34. So Ca is calcium is 40 atomic mass, oxygen is 16 and hydrogen is 1. So this comes out to be 74 grams.